Today we're going to talk about types of chemical reactions, and specifically we're going to focus on synthesis and decomposition reactions. You're going to use patterns that you see to predict the products. The products are the things that we write on the right side of the arrow. Okay, so here are the 5 types of chemical reactions. The first is synthesis. There's decomposition. These are the 2 types we'll learn about today. In the next video, we'll focus on the others. There's also single replacement, double replacement, and combustion. Okay, so during a synthesis reaction, 2 elements combine to make a compound. Here's the common form. Here's the pattern, if you want to call it that. You've got one element plus another element makes a compound. We can use symbols for this if we want. We can say A plus B makes AB. The compound is just the 2 things on the left side of the arrow put together. Think of the word combine. You've just combined them. Okay, so let me give an example of a synthesis reaction. Sodium plus chlorine makes what? Now, up to this point, I've given you what's on the right side of the arrow, but now you're learning how to predict the products. What will you make on the right side of the arrow? So notice this has our pattern. We've got one element plus another element makes what? When you've got that format, A plus B makes what? It's just AB. You put the 2 together. Same goes with magnesium plus phosphorus. It's one element plus another element makes this compound. Just put them together. Sulfur plus aluminum. Same thing, we're going to put them together. So in each of these examples, you've got a metal. Sodium is a metal and a nonmetal. So when that happens, when you've got a metal plus a nonmetal, you put them together. The metal always goes first, and the nonmetal goes second, and you change the ending on the nonmetal to "ide." So here we've got magnesium plus phosphorus makes, we put the name of the metal first, magnesium, and we take phosphorus and change the ending to "ide." Here sulfur was our metal. Aluminum was our metal. So aluminum goes first, and then sulfur is a nonmetal, so that's why we put it second. And we change the ending of the nonmetal to "ide." Okay, so those are some examples of synthesis reactions. Now, let's talk about decomposition reactions. So, in a decomposition reaction, a compound breaks down into the elements or the smaller parts of it, or smaller compounds. Okay, so here's the common form. It's basically the opposite of a synthesis reaction. Instead of having the compound on the right side of the arrow, now we have it on the left. So you start with the compound, and it breaks down into an element plus another element. So if we were using symbols, it would be like AB breaks down into A plus B. That's a decomposition reaction. Here's some examples. Say we've got potassium nitride. Notice those are 2 words put together. This is a compound. And potassium is my metal, nitride, that's the nonmetal. So when that decomposes, when that compound decomposes, you just split those 2 words up, put a plus sign in between them. So you've got potassium plus nitrogen. Now that they are separated, they're not joined together anymore, we've got to change the ending on the nonmetal back to its original ending that you would see on the periodic table. So potassium nitride breaks down into potassium plus nitrogen. Okay, now there are 3 special cases that you need to know about. for decomposition reactions. So the first special case is when you have a metal with chlorate. Now, chlorate is one of those polyatomic ions on your polyatomic ion sheet. Remember, if it ends in 8, then it's on that polyatomic ion sheet. So when you have a compound that's a metal chlorate, for example, say it's barium chlorate. Barium is the metal, and then you have it joined together with chlorate. This is my compound, barium chlorate. When that decomposes, anytime you've got a metal chlorate, it's going to have this form. It's going to be, you're going to make metal chloride plus oxygen. So every time you see on the left side of your arrow a metal chlorate, when that chlorate breaks down, it's going to make this chloride plus oxygen part. So let's look at this example. Barium chlorate, what's it going to break down into? It's going to break down into barium chloride plus oxygen. Every time you're going to see the chloride plus oxygen when chlorate decomposes. Okay, here's a second special decomposition case. When you have a metal carbonate, so again, see the 8 on this ending, that's one of the polyatomic ions. So these special decomposition cases, they involve polyatomic ions. So if you've got a metal with a carbonate, for example, say it's potassium carbonate, potassium is the metal, what is it going to make? It's always going to have this form. The carbonate will decompose into the metal oxide plus carbon dioxide. So look at our example here, potassium carbonate. When it decomposes, when it breaks down, you're going to get potassium, and then you add on this ending every time, potassium oxide plus carbon dioxide. So anytime carbonate breaks down, it's going to use the oxide plus carbon dioxide there. Okay, last case of special decompositions. If it's a metal hydroxide, again, hydroxide, you can look it up on the polyatomic ion sheet. What happens when some metal hydroxide decomposes? So, for example, say you've got tin hydroxide. What's going to happen? So, metal hydroxides break down into metal oxide plus water. So, if I have tin hydroxide, it's going to break down into tin oxide plus water. So those are your 3 special decompositions. Yeah, and I should mention, don't forget to write in the Roman numeral. So if you have the Roman numeral here on the left, you need to write it in again on the right. Okay, so those are your 3 special cases of decomposition, and that is it for this video. To review, you've learned about synthesis and decomposition reactions.